Hello, this lesson is on systems in two variables. And there are many methods to solve a system. You can use substitution, elimination, or the graphing method. And we're going to solve these systems algebraically, so that's either going to be with substitution or elimination. Okay, so what is a system of linear equations? Well, that's when you have two equations with two unknowns, so an x and a y. And so you can solve the system with substitution or elimination, and we're going to do substitution first. So the first thing you want to do is you want to pick a variable to solve for, and you always want to pick one that doesn't have a coefficient other than 1. So you could solve for x in the first equation, or even y in the first equation, even though there's a -1. I'm going to solve for x in the first equation. So that means I'm just going to move that minus y term over, and that gives me x equals y plus 3. So now x is in terms of y. X is y plus 3. So once you do that, that means you're going to substitute in for x in the second equation. So that would be 4 times y plus 3, as it was for x, minus 2y equals 20. And what you have done is now you've created an equation in one variable. So we have to solve for y. So that would be 4y plus 12 minus 2y equals 20. And then you have like terms on the same side, so you combine that. That's 2y plus 12 equals 20. So we're going to subtract 12 from both sides. So that's 2y equals 20 minus 12 is 8. And then we're going to divide both sides by 2, and you get y is 4. But since this is a system with two unknowns, you're only halfway done. You know y is 4, but now you have to find its x-coordinate partner. And when you do substitution, it's usually kind of dangling over here. X is already by itself. So that's the best place to go find x. So x equals 4 plus 3, so x is 7. So once you find x and y, it's important to write your answer as an ordered pair. So the solution is the ordered pair x, y, 7, 4. Okay, so this is an interval notation. What's happening is, if we were to graph this, y equals, if I solve for y equals x minus 3, would look like this. Y-intercept -3 and a slope of 1. So it would look like that. And this, if we were to graph this, this has an x-intercept of 5 and a y-intercept of -10. And so it would look like something like this. So two lines would intersect. See this intersection? That's this point, 7, 4. So the solution to a system of linear equations is often going to be one point, not always. If the system is consistent and independent, you'll have one solution. So make sure you write your final answer as an ordered pair. Okay, the other method is elimination. So with elimination, you want to make sure both your equations are in standard form, which is ax plus by equals c. And so start out, both of those are in standard form. So elimination is when you use multiplication to get opposites, so that when you add the two equations together, one of the variables cancel out. So there's something called a target number. If I want to eliminate the x's, then the least common multiple of 2 and 3 is 6. So I could multiply this top equation by 2 and this bottom equation by -3 to get 6x and -6x. I could do that. Or I could look over here and see the least common multiple of 4 and -1 is just 4. Okay, so this is a little less work because there's already a 4y here. So I'm going to rewrite that. 3x plus 4y equals 5. And I'm going to multiply this bottom equation, both sides, by 4. Now, the reason I'm multiplying by 4 is because my target number is 4y and negative 4y. I want opposites. So I'm going to multiply both sides by 4, which means I have to distribute this 4 to all 3 terms. So 4 times 2x is 8x, and 4 times negative 1 is negative 4y, and 4 times 9.5 is negative 38. Okay, so once I get opposites, I always am going to add. Now, the reason I like to always add is because if you subtract, you have to remember to distribute the negative, which is, again, one of my top 5 errors people make. So this is just less work to make sure we have opposites than we can add. So a 3x plus 8x is 11x, and 4y plus a negative 4y, 0, and 5 plus a negative 38 is negative 33. So now again, I have one equation with one unknown that I can solve. So I'm going to divide both sides by 11, and x is negative 3. Okay, now just like before, that's just part of the answer. We have to find the y-coordinate partner with that. Okay, so what you can do is pick either one of these equations. It's not quite like substitution where it's just obvious that that would be the best place to go. So you can pick whichever equation you want. I like to usually pick the ones that don't have negatives. So I'm going to pick the top equation, and that would be 3x, but now I know x is negative 3, plus 4y equals 5. So that would be negative 9 plus 4y equals 5. Add 9 and you get 4y equals 14. Divide by 4 and you get y equals 7 over 2. Okay, now don't forget to write it as an ordered pair. Don't just circle the answers. You have to write it as negative 3, 7 halves. So what that means is these are two linear equations. They're lines. If we were to graph them, they would intersect at that point. All right, one more thing I want to show you that you can always do, and that is you can always check your answer. So what we can do is we have to check both equations. We can put these values in for x and y. So if we check the top one, 3 times negative 3 plus 4 times 7 over 2, when I hit enter, it should equal 5. And it does. But you have to make sure you check both of them. It has to be true for both of them. So 2 times negative 3 minus 1 times 7 over 2, when I hit enter, should equal negative 9.5. So if you check both answers, then now you know for sure that's correct. So you can always do that. Okay, so examples 3 and 4, you get to decide what method you would like to use. So these two are in standard form. So I'm going to use elimination. It's not a good idea to use substitution because not one of these x and y variables has a 1 as its coefficient. So it's not a good candidate for substitution. So my target number, if I want to get rid of the x's, would be 4. So this is already 4, so I want this to become a negative 4. And the method we use is always multiplication. So what times 2 would give me negative 4? Well, that's negative 2. So I'm going to multiply this top equation by negative 2 and get negative 4x plus 12y equals negative 18. And then down here, I don't have to multiply by anything because there's already a 4x. And something interesting is going to happen here. Okay, so now it's time to add. I can add when I have opposites. So negative 4x plus 4x is 0. And 12y plus a negative 12y is also 0. So you have to put a placeholder there for the left side, 0. But on the right side, we have negative 18 plus 27 is equal to 9. All right, remember solving is trying to find the x's and y's that make this a true statement. And so the algebra is telling me that no matter what I do, I'm going to get a false statement because there's no way 0 is going to ever equal 9. So when that happens, that's just no solution. Now, graphically speaking, what is happening is, if you notice, you can see that this 2 is a multiple of 2 and 4 are multiples. 6 and 12, if you multiply by -6 by 2, you also get -12. So this left side, you have the same multiples, which means you have the same slope. And then here, they're not multiples of 2, so that's not the same y-intercept. So these, what's happening here is you have parallel lines. And when you have parallel lines, they never intersect. And so that's why it's no solution. But the algebra is going to look like this. When you get a false statement, then you're going to have no solution. All right, now this one, you could use elimination, but it's going to take some work. You would have to move this 4y over. You'd have to multiply both sides by 3 to get rid of the fraction. And you could do that, but this has a 1x, so I'm going to use substitution here. So I'm just going to move this minus 4/3 y over. So that's x equals 4/3 y plus 4. So if I solve for x in the second equation, that means I need to substitute in for x in the first equation. So that would be 3 times 4/3 y plus 4 is equal to 4y plus 12. So now I have one equation with just y, so I can solve that. I'm going to distribute. Remember, 3 is 3 over 1. So 3 times 4/3, the 3's divide out. That's just 4y. And then 3 times 4 is 12, and it equals 4y plus 12. So we have the same exact expression on the left as we do on the right. So we can go through the motions. We can subtract 4y from both sides. That gives me 12 equals 12. So this is a similar situation as here. The variables just go away and you get this 12 equals 12. This time that's a true statement. Now the solution isn't true. You have to interpret that. What that's saying is that it doesn't matter what you put in for x or y. No matter what you put in for x or y, you get a true statement, which means that there are infinitely many solutions. Now, I'm writing that down because that might be where you stopped in a previous math class. In this class, we go a step further. Okay, so what we're going to do is we're going to use this. We're going to write this in set builder notation, because it's not just any old infinitely many solutions. It's only the solutions that fit this pattern. Okay, so what that means is, for example, let's say I let y equal 1, then x is going to equal 4/3 times 1 plus 4, and that's x equals 16/3. So 16/3 and 1 is the solution. Now I'm going to be smart about the y's I pick. Let's say I let y equal 3, then x would equal 4/3 times 3 would be 8. So 8/3. Let's say I let y equal 6, then x would equal 8 plus 4 is 12, and that would be 12/3. Now I could keep going on forever and ever. There are an infinitely many solutions, but you have to write down the rule. So here's how you would write your answer here. You would write all the ordered pairs x, y such that, so that bar means such that, they fit this rule. X equals 4/3 y plus 4, and y can be any real number. Okay, so that notation, y, that means is an element of, and that double barred r means any real number. Okay, so we go an extra step there. That's set builder notation. You could also write it this way. We allow you to write it this way. The ordered pair, 4/3 y plus 4 is the x value, and y is y. So I could put 1 in for y and get an answer. I could put 3 in for y, get an answer. Put 6 in for y, get an answer. You put 7 in for y, get an answer, even though it would be a decimal or a fraction. But there are an infinite amount of solutions. So we go further than just that. We have to write the rule that shows the relationship between x and y. Okay. What's happening there is that if you were to graph these two, it would actually be the same line on top of itself. So it would look something like the same line right on top of itself. Okay, so it's time for you to practice. So you can pause and try this. So what I want you to do is practice using substitution first. Okay, so pause and try that, and then come back and see how you did. Okay, so x plus 2yx, this x right here is the best candidate. You don't want to use substitution where you have to divide by a number. So you want your coefficient to be 1. So I'm going to solve for x by saying that's x equals negative 2y plus 1. So just move that 2y over. So then I'm going to substitute in for x in the second equation. And then I need to distribute. And then I need to add like terms. That's negative 14y plus 5 equals negative 23. Then I need to subtract 5, so that's negative 14y equals negative 28. And then I need to divide by negative 14. I get y is 2. Now remember, the good thing about substitution is you're now trying to find x, but there's a place where x is already by itself. So x equals negative 2 times 2 plus 1. So the ordered pair is negative 3, 2. All right, we tried this one. The best variable to solve for is x in the second equation. So one of the things you can do is you can change the signs of these. It's kind of like multiplying by negative 1. So if I multiply this side by negative 1 and that side by negative 1, that becomes positive x minus 2y equals negative 21. So x is equal to 2y minus 21. So I solved for x in the second equation. So I'm going to plug in for x in the first equation. All right, so distribute 14y minus, need my calculator for this. 21 times 7 is 147. Plus 2y equals negative 19. And then 14y and 2y is 16y equals 147 minus 19 is 128. And then divide by 16. And y equals 128 divided by 16 equals 8. Okay, so then I got to go find its x-coordinate partner. There's a great place to go find x. So x equals 2 times 8 minus 21. So x equals 16 minus 21, which is negative 5. Don't forget to write the ordered pair. So you've got to put it in order, negative 5, 8. All right. Don't forget to do that because I'll count off. You have to make sure you can understand that the solution is the ordered pair x and then y. All right, now pause the video and practice using elimination, and then come back and see how you did. Okay, so number 3, you have 5x plus 6y equals 24 and 3x plus 5y equals 18. They're both in standard form. That's good news. So I'm going to decide to get rid of the x's. That's the elimination method. So my target number of 5 and 3 is 15. So I'm going to need to multiply this top number by 3, top equation by 3 on both sides. And then I want negative 15 on the bottom. I like opposites. So I'm going to multiply the bottom equation by negative 5. I always use multiplication. Okay, so that gives me 15x plus 18y equals 24 times 3 is 72. So that's the first equation. And then negative 5 times 3x is negative 15x, and negative 5 times 5 is negative 25y. And then 18 times negative 5 is negative 90. All right, now I'm ready to add. So they add to 0. 18 minus 25. 18 minus 25 is negative 7 equals 72 minus 90 equals negative 18. Divide by negative 7 and you get positive 18 over 7, which is kind of a nasty answer. I can already tell you I'm going to check my work here because that's a little scary. All right, now I need to go find x. Doesn't matter which equation I pick, so I'm going to pick the bottom one. The numbers are slightly smaller, not much smaller. So 3x plus 5 times 18 over 7 is supposed to equal 18. So 3x, all right, so here we go. 5 parentheses 18 over 7 is nasty decimal, so we got to make sure we use fractions. You can multiply through by 7 to get rid of the fractions if we want, but we also have this calculator. So the algebra here is I'm going to subtract 90 over 7 from 18. So 80 minus 90 over 7 is another decimal, hit the squiggle, and that gives me 36 over 7. So 3x equals 36 over 7. Now I'm going to divide that answer by 3. So I'm just going to leave that in there, divided by 3. Get 12 over 7. Okay, so my ordered pair is 12 over 7, comma, 18 over 7. That answer looks a little sketchy, so let's check our work. You know how to do that? Did we see that? Okay. All right, so let's check our work. So we're going to plug in 5 parentheses 12 over 7 plus 6 times 18 over 7. And when I hit enter, it should equal 24, and it does. Got to check both of them. 3 times 12 over 7 plus 5 times 18 over 7. When I hit enter, it should equal 18, and it does. So even though those solutions are kind of ugly in proper fractions, that's the correct solution. And that's why solving these by graphing is not a good method, because it's really hard to pick up those exact answers off a graph. All right. Now, number 4, I don't know, you might want to pause if you haven't tried it yet. But it's not in standard form. Remember, standard form is ax plus by is equal to c. So this constant, negative 16, needs to go over here. And this is just kind of written in the wrong order. So I'm just going to rewrite this as 20x minus 8y is equal to positive 16. And then this one, you're not going to move things. But the equal sign is symmetrical, so I'm going to just write that first, not changing the signs though. That's negative 22x minus 18y equals 36. Okay, so we have two equations now in standard form, and now it's time for me to mention a little trick. You can reduce these. So 20 and 8 and 16 have 4 in common. So before you begin this work, if you want to make the numbers smaller, you can. You don't have to, but it is legal to divide both sides by the LCD. Whatever you do on one side, do on the other. Least common multiple, excuse me. So if I divide this by 4, I'm going to get 5x minus 2y equals 4. Same thing here. 2 goes into all 3 of these, so that's going to be that by 2, divide that by 2. That's going to be negative 11x minus 9y equals positive 18. So it just makes the numbers a little smaller. Again, it's up to you. All right, now I've got to figure out a target number. And I'm going to use this negative 2 and this negative 9. So the least common multiple of 2 and 9 is 18. So I need to get 18 up here, and I need one of them to be a negative 18 and one of them to be a positive 18. So I'm going to multiply this by negative 9. So that's negative 45x plus 18y is equal to negative 36. And so then down here, I don't need to multiply by a negative number. I just already have a negative, so I'm just going to multiply by 2, and that's negative 22x minus 18y equals positive 36, which you might notice is what we started with. Okay, now if I add, I get negative 45 plus negative 22, which is negative 67x is equal to 0. Don't panic about that. So that's the x is still there. We're just going to divide both sides by negative 67. Ends up being x equals 0. Okay, so now we need to go find y, and I'm going to go to this bottom one. So that's 36 equals negative 18y minus 22 times 0, which is 0. So divide by negative 18. So y is negative 2. So the order pair is 0, negative 2. And then you could check your work and make sure that's okay. Okay, so that's the lesson on solving systems in 2 variables, and find some to practice in the textbook. But I did want to finish with 2 word problems. So over on the back, we've got a couple of word problems. And this one is a special one where once you see how to do it, you'll hopefully categorize that and say, oh, I remember how to do these types of problems. So it says, a boat on a river travels downstream between 2 points 20 miles apart in 1 hour. So we have distance and we have time. Okay. And it makes its return trip against the current, and it takes 2.5 hours, so another time. And it's the same distance because it says return trip. And we want to find the speed of the boat, otherwise known as rate of boat. And you want to find the speed or rate of the current. Okay, so the way that these systems of word problems, the systems of linear equation word problems are going to work is a lot of times you can look at the question if it's given to you, and you can see what you're looking for. You're trying to find 2 different things, speed of the boat and speed of the current. So you want to define your variables. So we're going to so we're going to let x equal the speed of the boat and y equal the speed of the current. Okay, so once you have your variables defined, then this is an interesting type of problem, but once you've seen it once, you'll be able to do it. When you've got distance equals rate times time problem, and you've got downstream and upstream or against the current, or if it were a plane, it might be tailwind or headwind. You're going to, best bet is to make a table. And so the table is going to look like this. You're going to have 2 rows, and one of them is going to be downstream and one of them is going to be upstream. And then across the top, you're going to have rate times time equals distance. Okay. And so you have to understand what downstream means to understand how to write the rate. So the rate is the speed, and you've got 2 speeds. If you've ever been in a canoe, you understand this. You've got the speed of the boat, which is coming from you rowing, and you've got the speed of the current. And if you've ever been going downstream and you've got a fast current, that's your time to take a break. You don't necessarily need to row. So when you're going downstream, the speed of the boat, the speed of the current work together, so that would be x plus y. But when you're going upstream, that's when you have to work hard because the current is trying to make you go one way and you want to go the other way. So you have to row against the current. And hopefully you're able to go faster than the current. So this upstream rate would be your rowing x speed of the boat minus the speed of the current. Okay. Then your time, you have to read, it says that when you're going downstream between 2 points 20 miles apart, it takes you 1 hour. But when you're going against the current, it takes 2.5 hours. And then equals distance, the distance is the same because you're going one place and coming back to the original, so 20 and 20. And so that gives you a chance to write two equations. So I wrote those over here. So rate times time is x plus y times 1. And I wrote the constant in the front. And it may not be a 1. It might be 2 hours or 3 hours. So I wrote it down just to show you what you would do. So you have 1 parentheses x plus y equals 20 from that row. And this row would be 2.5 times x minus y equals 20. Okay, so then I wanted to show you a little trick with these. Instead of distributing the 2.5 and the 1, you can divide out that number as long as you do it to the other side, and that just gives you plain old x plus y equals 20, and you could divide out the 2.5 on both sides, and that gives you x minus y equals 20 divided by 2.5 is 8. So now you already have, if you want to use elimination, you already have opposites. So you get 1x plus 1x is 2x, y plus a negative y is gone, and 20 plus 8 is 28. Divide by 2, and you get x is 14. Now again, with every single word problem you ever do, you have to give me the units. So up here I have x is the speed of the boat, and speed is rate. So if I solve d equals rt, for r I get d over t. D stands for distance, and distance is in miles, and t is time, and it's in hours. So the rate units are miles per hour. So you always need units in a word problem. So not just the number, you got to give me the units. So you have to think through that. And x is the speed of the boat. So 14 miles per hour is the speed of the boat. Now I need to find the speed of the current. So I'm going to take this equation, x plus y equals 20. So x plus y equals 20. Plug 14 in for x, and you can find out y is 6. And then that would be y is speed, so miles per hour, and that's the speed of the current. All right, so the last word problem example is a traditional one. It's doesn't have you don't need a table. What you do, first thing you want to do is read through the problem. The admission fee into a park is $1.50 per child and $4 per adult. If 2,200 people entered the park and the total fees were $5,500, the question is how many children, how many adults entered the park? Well, we can see that we're given ticket amounts per child and ticket amounts per adult, and we're given total amounts. So we're going to use the question that we're given. The question's not always given, but it might be below, part B or something. But I like to use the question, and it says, how many children? So X is the number of children, and Y is going to be the number of adults. And so then you need to write, you got two different variables, so you need two equations. And so for these types of problems, you're given total amounts a lot of times. So you have a total people amount of 2,200, see that? And you have a total money amount of 50/50. So you're going to write a total people equation. Well, people are made up of children and adults. So x plus y, the number of children plus the number of adults, is going to equal 2,200. Okay? And then the fees are $5,050. Well, where's the money come from? Well, they charge $1.50 per child, so that would be 1.5 times the number of children, and they charge $4 per adult, so that would be $4 times the number of adults. And when you calculate that, it's 50/50. So we have our system of equations. I call these total. You get given two totals, so you write the equation. Now you can use elimination or you can use substitution. I'm just going to use substitution here. So I'm going to solve for y, and that's 2200 minus x. And then I'm going to substitute in for y, so that's 1.5x plus 4 times 2200 minus x is 5050. So that's 1.5x plus 8800 minus 4x equals 50/50. And then 1.5 minus 4, 1.5 minus 4 is negative 2.5x. I used to get nervous when I got a negative on this side, but that's okay because when I subtract 8800, I get a negative on the other side. So 50/50 minus 8800 equals negative 3750. So yeah, x has to be positive. X is the number of children, but when I divide by negative 2.5, a negative divided by negative is a positive. So divide by negative 2.5, and we get x is 1500. So again, you want to make sure that you give me units. So you got to look at the Math English Dictionary. X is number of children, so there's 1500 children. And then we have to go find y. So the best place to find y is where y is already by itself. So y equals 2200 minus 1500. And so y equals 700, and y is number of adults. So 700 adults and 1500 children. Okay, so that's just a couple of word problems there for you.